All right, Chuck.
Rock and roll.
Do you want the hand mic or?
Oh, I'll do this guy here.
Yeah, this was a one found on Google Earth, believe it or not. Somebody suggested it, and a few geologists went and looked at it, and lo and behold, yes, it is a crater, which is a great segue into my talk tonight. I'm going to kind of give you some hints on what to look for if you're looking for a meteorite crater. When you're tromping through the bush and you see something strange, hey, you just might find a crater. And if it is, you'll be famous. But as your coordinator of meteorite craters, I'm going to give you some news on what happened in the solar system in the last little while. This one on the moon is a brand new crater compared to the, let's see if I get this right. Whoa, what happened? Yeah, there we go. Oh, there it is. Okay, I pushed the wrong button. Apollo 15 picture, and just recent, 2009. So the moon is still being peppered. Mars got zapped just a little while ago. And this is a real weird one. I want to show it to you, not that it's a new one or not, but here's a crater within a crater. Now, what's the chances of a impact inside a crater? You know, this is on Mars, and the geologists are still mulling over this because this one looks fresher, but there's no ejecta, it seems, from it. So it could be a collapse within the center part of the crater or not. So next time I fly out there, I'll take a look at it.
Ask Rolf to do a better image.
Yeah, yeah, Rolf, let's get in there. But this is a real weird one. But the chances of a crater within a crater is, well... And just to show that we're still in the shooting gallery, Jupiter just a little while ago got hit as well. So it's happening. Peter Saravallo, are you here tonight? In the GA in New Brunswick, we had an excellent presentation on meteorite craters by a guy from University of New Brunswick. I can't remember his name.
Was it Paul Gray who did that? Was it Paul Gray?
No, it wasn't. Anyway, his final part of the presentation was what can we do to prevent these things from hitting us and so on. And essentially it's worldwide cooperation. And Peter came up with the quote of the whole meeting saying, well, looks like we're toast. Because it's not a case of if it's going to happen, it's I guess it's when. So the dinosaurs didn't have a space program. We better get bucking on here. Anyway, I can't remember why I put that in there, but I love it anyway. These two craters, they're right by the Apollo 11 landing site, but looking at those through the telescope, you'll get a good appreciation of what crater sizes look on our planet, because they're the exact same size and orientation of the Clearwater craters in northern Quebec. These guys right there. And this is just a little history, 1950s. This is a very new science, crater studies. And this is pretty well what we knew about craters in the 1950s. And 20 years later, we've got that. This is just in Canada. And now there's over 250 craters known on this planet. And what I like to say is within a day's driving distance of where you're sitting right now, there are 10 major meteorite craters you could visit. Just give you something to think about. So, how do we identify a crater? Well, first thing, Eric and I went up and took a look at this guy. And circular. Well, the one they found on Google Earth, the one in Egypt that I told you about, was a circular object they found, and they investigated it, and yes, it is a crater. And this is the Chubb crater up, or the New Quebec Pingualuit crater up in northern Quebec. Brand new, 60 million years old. And Eric and I camped there, walked up here, and explored right around this guy. That was quite the trip. Hey, Eric.
Where did you land?
Actually, there's a park here now, and there's a small strip right there. I didn't land myself. I came in with a twin otter. A couple of girls, they were late 20s, I'll tell you. And these girls knew how to pilot that airplane.
They sure did.
And they 500-foot long runway, and they got her in and out. No problem at all.
An aircraft carrier.
Yeah, exactly. It was cool. But anyway, the airport's right over there, And it's a good, 2-3 kilometer walk up here, and it's not an easy walk either. So, circular. Well, here's two circular objects. Which one is an impact? One is, one isn't. Let's figure this out. Well, what do we look for? Well, first of all, we look for circular objects, right? And we'll go to Manicouagan, and yes, it's circular. Wow, and I love that picture. Yeah, I got a good thermal on that one to get on that picture. I just want to mention, if you ever look at the Manicouagan Crater, Eric and I explored in this little area here. A lot of good sights to see, we'll show you in a second. But if you notice here, look at this circular object. And I mentioned that to the professor at the University of New Brunswick, and he said, maybe. Nobody's really explored it, so it's a case of, well, it might be and it might not be. So Eric and I are going to go there someday, and we'll be famous if we find. But what are we going to look for? Well, on the way to Manicouagan, there's shattered rock. Yeah, it could be. This is about 60 kilometers away from this point zero at Manicouagan. And, you know, we've all driven through the Canadian Shield and saw the rock cuts of the solid rock. Well, this is what it looks like when it got zapped by a meteorite, a large one. Impact breccia. This is impact melt around here. This here is the country rock that got blasted out of the hole and then plop, plop, plop back into the lava. Yeah, that could be a sign of a meteorite crater, but naturalistic around volcanoes could be the same thing. More breccia, yeah, getting closer. And I just wanted to bring this up. This is a good tourist shot. Here's Chuck peddling his brains out and Eric taking pictures all the time. But anyway, we're heading for this cliff in the background is an impact melt picture. And this was just a good tourist picture. And I read a paper later that showed a real cool anomaly on that cliff. And this is a picture from Eric right there. That is a large piece of country rock. Now just let me get my statistics. What you're looking at here is impact melt. This used to be about 2 kilometers thick at one time. Now this is 240 million years ago, so there's been a few years of erosion. But here we go. This rock basically got ballistically blasted out of the crater. You got all the impact melt from the impact, and this big rock goes plop into the lava, and it starts to sink. Where are we here? Okay. The rock is 3 grams per cubic centimeter more dense than the melt. So you have a constant rate of sinking. So the paper was dedicated to the study of, the rate of sink of this rock, which would give a rate of the quenching of the impact melt. It was a fascinating paper, lots of mathematical equations on it. I'm sure everybody would love it. But anyway, this was a real unique shot, and Eric and I were just taking random pictures, and it was just awesome. We got this one. And this is a pure cliff of impact melt. Yes, this could be, if you see a cliff like this and it's impact melt, if you identify it, you might have a meteorite crater. But the main point of this whole talk is how you and I, looking at rocks, can identify it. Well, I took this picture, and I looked around, and I looked down, and what did I see? A shatter cone. Now, this is something that you can see with your eyeball that is very unique to a very high-pressure explosion, a nuclear explosion or an impact. 240 million years ago, nuclear explosion. 240 million years ago, a large impact. Well, I'll go with the impact. So, shatter cone. I've got one here I'm going to put out. It's not a door prize. You can look at it during the break. Take a look at it during the break and study it. And if you see something like that while you're walking through the bush, you've found yourself an impact crater. This is just another tourist site from Eric and I. We were marooned on this island for 22 hours. Nice calm weather we found. And here's a canoe back here. You can see the size of the canoe relative to the waves. And that canoe was full of rocks. Yeah. We barely made it on that island. We lit a fire, dried ourselves off, and 22 hours later, in the middle of the night, it calmed down and we just hightailed it out. But we had enough food for another 5 days.
It was great.
Yeah, we would have made it. What a trip that was. Anyway, so getting back to which one is the circular one and which one isn't, let's go to Slade Island, and I'll show you another shatter cone. This here is the largest identified shatter cone on the planet, and that's me for scale. So it gives you an idea how big these guys are. So, which one is the impact structure? This one here is Lake Scutamata, just by the Bon Echo Lake. Eric and I just flew over that today. Before I go on, Bon Echo is very unique. It used to be all ocean around here, and as the ocean receded, some biology was left behind. Well, Bon Echo has a freshwater shrimp in it. It's the only one in the world, apparently, from the ocean. So it evolved into being a freshwater shrimp. And up here, this is Presqu'île in northern Quebec.
Chuck, remind him that's where Nirvana is located also.
That's right, yes. We took a picture of Nirvana for the observers later. We saw it from the air. Instead of looking from there looking up, we were up there looking down. So this is where Presqu'île is, up in northern Quebec. That is an impact site. The other one was not. Scutamata was a geological feature. Very circular, though. These are shatter cones at Presqu'île. Scale my finger, and there's a shatter cone there. This one here, an interesting story. Eric and I were paddling along Presqu'île, enjoying life. All of a sudden, this big rain shower, black cloud was coming towards us. So we paddled like heck. Well, I did. Eric was taking pictures. We got into the lee of an island and waited there. And yeah, it was quite a storm, and we were sitting there discussing life, the universe, and everything, and it rained and rained and rained. So I said, what the heck? I'm going to get out and look around. The first rock I picked up was a shatter cone. Awesome.
I was joking.
Yeah,
I
Eric was
saying,
joking.
Look, there's a shatter cone, and he looked.
Yeah.
I'm sure there was one.
And I picked it up. There it was. So that's how you can identify a shatter cone. I'm going to leave one out here. Take a look at it at the break. If you see one in the bush, you're going to be famous. Sorry, Brian, I was as fast as I could.
Oh, no, that's good. That's good. Thank you, Chuck. Okay. Yeah, that's good. Thanks a lot, Chuck.
Okay, shatter cone right here after the break.
Okay, the non-door prize. The non-door prize. That's right.